Alright, so we're going to continue with resultant force on an object in various states of motion. In this lesson, you should be able to communicate about resultant force when an object is stationary, moving with a constant velocity, or moving with a constant acceleration. Now, let's look at this example here. The ball is at rest. Now, when the ball is at rest, what can you say about the acceleration? Acceleration is 0, correct. Now, is there any forces acting on the ball? Well, actually there is. Any object, if it has mass, meaning it has weight. Alright, now we're going to draw a free body diagram. Now, free body diagram would be a diagram where you label all the forces that are acting on the object. In this case, we have weight. Alright, then of course, since the ball is in contact with a surface, so it should have a normal reaction force. Now, the acceleration of the ball is 0. Since the acceleration is 0, it means the resultant force is also 0. Alright? The resultant force is 0. Okay. In this case, since the resultant force is 0 Newton, we can say that normal reaction is equal to weight. Meaning, if my weight is 20 Newton, then my force should be exactly 20 Newton. Alright, so how do I know my normal reaction is 20 Newton? Because previously, from our previous lesson, we know that to get resultant force, if the forces are opposite in direction, it should be, we should subtract the forces. So 20 Newton minus 20 Newton, you get 0 Newton. That's how I know my normal reaction is 20 Newton. Okay, so remember, if the ball is at rest, it means the resultant force is 0 Newton, always. Alright, so now we're going to practice some free body diagram drawing. Okay, now if you look here, you have a car on an inclined plane. Alright, now let's practice drawing free body diagram. Meaning to say, to draw all the forces that are acting on the car. So tell me, what is the first force that are acting on the car? Of course, you have weight. Other than that, since the car is in contact with the plane, so it should have a normal reaction force. Alright, now let's look at the free body diagram. Now, when you want to draw a free body diagram, always start with center of mass, which is a yellow dot there. Okay, there. That is my center of mass. Then we are going to draw all the forces. First, here you have normal reaction force, which is always 90 degrees to the surface. And then we have weight, which is exactly to the center of the earth. Another one that we have here for this example would be frictional force. You should have frictional force for this one. Why? Because if you don't have frictional force, what do you think will happen to your car? If there is no frictional force, your car will slide down. So the reason why your car stay at rest is because there is a frictional force between the tire and the ground. Alright, so now let's look at this rocket here. The rocket is launching, meaning is it still on the surface? It's not. Alright, so now we're going to draw a free body diagram for this rocket. Always start with center of mass and then label all the forces. First, definitely you have weight. What else do you have? Do you still have normal reaction force for this one? No. Why? Because it's no longer touching the surface. So what do we have now? What caused the rocket to launch upward? That would be thrust. Alright, the driving force that caused the rocket to launch upward. Thrust. And then, since the rocket is moving upward, definitely you have some air resistance. Not much, okay? A little bit of air resistance, which is always in opposite direction as the rocket. Alright, so now let's look at this example here. We are going to describe the resultant force on an object when the car is at rest. So what can you say about the resultant force when the car is at rest? Correct, it is 0 Newton, which we have previously learned in the first part of the lesson. Resultant force is 0, alright. Why? Because the acceleration is 0. Since the acceleration is 0, the resultant force is also 0. So now we're going to draw a free body diagram for the car. First, you have weight always, and then definitely you have normal reaction force. Now, do you have thrust for this one? Is there any driving force going on for the car? No. Why? Because the car is at rest. So we can say that normal reaction force is equal to weight because the resultant force is 0. Alright, so now let's look at this example. Describe the resultant force for the object when the car is moving with a constant velocity. Alright, constant velocity. It is moving but with a constant velocity. What can you say about the acceleration for the car? The acceleration is 0. Now, since the acceleration is 0, what can we say about the resultant force? The resultant force is also 0. Alright, so now we're going to draw a free body diagram. First, always start with center of mass. And then, of course, we have weight. Since the car is touching with the ground, so we are definitely going to have normal reaction force, which is 90 degrees to the surface. And then since the car is moving, so of course we have thrust. Then definitely we are going to have frictional force. Alright. So now, since the resultant force is 0 Newton, what can you say about the forces along the x direction? Can you compare thrust and frictional force? Correct. Since the resultant force is 0, so my thrust is exactly the same as frictional force. But of course, it is in opposite direction. So my frictional force is the same as thrust. If my thrust is 200 Newton, then my frictional force would be exactly 200 Newton, given that the car is moving with a constant velocity, all right? Now let's look at the third example here. We are going to describe the resultant force on an object when the car is moving with a constant acceleration. Alright, there is an acceleration. So my acceleration is non-zero, ada nilai. What can you say about my resultant force? It will also be non-zero, alright? Remember, resultant force is closely related to acceleration. If my acceleration is 0, then my resultant force is 0, alright? So now we're going to draw a free body diagram. Let's look at this car here. When drawing free body diagram, always start with center of mass. And then we have weight. And of course, we have normal reaction force. Since the car is moving with an acceleration, so we are going to have thrust. And then we have frictional force. Alright? Now, let's compare thrust and frictional force. Alright, let's compare the forces along the x direction. My resultant force is non-zero, meaning there is a resultant force. So, one of the forces have to be larger than the other one. Which one is it? Of course, it will be my thrust. So, my thrust is more than my frictional force, meaning my resultant force would be along this direction. Okay, meaning my car would also accelerate to the right. Alright. So we are going to go back to our first slide. Okay. Okay. Right. Now let's summarize a few things. When the car is at rest, right? When the car is at rest, meaning my acceleration is 0. Since my acceleration is 0, my resultant force, which I'm going to write as F net, is also 0. Now, what about if the car is moving, but with a constant velocity? If it is moving with a constant velocity, what can we say about the acceleration class? Acceleration is also 0. So, what can we say about my resultant force? Also 0. Very good. Now, let's try the last example. The car is moving, but with a constant acceleration. Alright, so what can we say about my acceleration? It is non-zero. Since it is non-zero, so my F net is also non-zero. Alright, so these are the important things that we learn in this lesson here. So I hope you understand it. If you have any question, please ask. All right, so that's it for this lesson. Thank you.